Members, please, let's be
Yes.
serious. Let's be serious and attend all lessons. Okay? Okay?
Yes.
Are you able to see my screen?
Yes.
Okay.
Yes.
Where is, let me check this book for you. Then we start our lessons, okay? So we have finished we have finished indices and SADs. Is there any question on those two areas, members? I think there is no question on that, right? So the other time people discussed, that was good. People discussed and we did some revision on logarithm and SADs. I mean on indices and SADs, and we did it well. So, and I believe after that, no one should be having any problem to do with the indices and SADs. So today we want to look at logarithm. But before we go to logarithm, I just want to have a brief memory on what we have already started. And I remember very well, I'm the one who taught you that. That was standard form. So can we start by writing standard form? Standard form. Let's start from there. Standard form. Or some you call it standard notation. Standard notation. Standard notation. Members, are you able to see my work well?
Yes.
Okay, so let's start with standard form or standard notation. So who can remind us what is standard notation? Who can remind us? We said, let me write this one down. It's not on the screen. In mathematics, and science, mathematics and science, we often use very large and small numbers. Large should be or, not and. Large or small numbers. Small numbers. And small numbers. Such numbers are best written. Best written in scientific notation. Best written in scientific notation or standard form. Best written in scientific notation or standard form. Full stop. So when writing big or small numbers in standard form, comma, there is only one figure. There's only one figure or digit before before the decimal point. Before the decimal what? Point. Members, when writing big or small numbers in standard form, there is only one figure or digit before the decimal point. The decimal point. Full stop. Full stop. Full stop. Full stop. The given number is expressed as one figure, between 0 and 10, between 0 and 10, or none, 0. Members, are we together?
Yes, we are together.
Very good, please. So we want to look at logarithm, but before we look at logarithm, it's very important for us to also to understand standard form, because they move hand in hand. They move hand in what? Hand in hand. And I request, please, members, when we are having lessons, make sure that you are in a quiet place, not in a noisy place. Sit somewhere where there is no one to disturb you, so that I don't want to get those feedback. Sometimes I need you to talk, because when your background is noisy, I may not be able to hear you well. Okay? Yes, move away from TV and other sources of noise. Yes, so we said they are written in a form. They are written in the form a times 10 to the power n. They are written in the form a to the power n. Full stop. Now, members.
Yes, teacher.
We are going to express. We are going to express these numbers in the following in standard forms, just briefly, so that when we come back in the second session, we go back to we look at what we go for logarithm. Okay.
Yes.
So let's start with the positive powers. Subheading positive powers. Positive powers. So the question is, express the following numbers. Express the following numbers in standard form. Express the following numbers in standard form. A. Members, I have 3,200. What is this one in standard form, members? We said when we are writing numbers in standard form, the first number, which is A, must be a single digit before a decimal point, must be a single digit, and that digit must be a non-zero. That digit must be a non-what?
Zero.
Zero. So what is going to be this one? This one you're going to say 3 point?
3 point.
3 point? 3 point. You
10.
So what you do, you ignore these zeros. The numbers must be non-zero. So you ignore these zeros. Are you together, members?
Yes.
So you're going to say 3.2. Then you multiply it by what? Times what?
10.
Times 10. Now you move. How many decimal points should I move to 3? So this is it. 1, 2, what? 3. Are you seeing that?
Yes.
So when you are moving, when you move from left to right, I mean from right to left, the powers is positive. The power is what? A positive power. So which means these are the power to the power what?
3.
To the power 3. What about B? B we have 8,200,000. 200,000. What is this one in standard form, members? So it's going to be 8.2 times 10. How many steps do we need to move? 1, 2, 3, 4, 5, 6. So the power what?
6.
to the power 6. C, what about 100? Write for me 100 in standard form. What is 100 in standard form? Who can write us 100 in standard form?
1.0.
Is going to be 1.0, good, times 10 to the power
10. 2.
10 to the power what? 10 to the power
2.
2, good. D, what
Teacher,
about?
question.
Yes, please.
What if we say 1 times 10 power 2?
You have to, because the reason why we put 0.0, so that we know the number, so that you avoid making mistakes, because the number that come after this is a 0. I think that the number after 1 is a what? Is 0.
0.
Okay?
Okay.
Yes. What about this one? 80,300. Who can write for us this one in standard form? What is that one in standard form? Yes, please. I said, please, let's minimize the noise in the background, please. That's why I want you to talk. I want you to talk. So let's go away from where the sources of noise. Who can write for us this one in standard form? This one in standard form is going to be 8 point. It must be only single digit before a decimal point, a single digit. 0.0. So that remember, there's the next number after 0 is what? A 3. So don't leave out that 0, that 3, because it's a non-zero. Because when you leave out, when you put here 0, which means when you express that, it will not give us back this number. The purpose is we are just expressing big numbers or small numbers in the standard form, but it should not change the meaning. It should not change the what? The meaning.
The meaning.
Yes. So which means this is going to be 8.03 times 10 to the power 1, 2, 3, 4. To the power what? To the power 4. Members, are we together?
Yes, teacher.
Now, how do we press these values in our calculators? Can you pick your calculator, members? Can we pick our calculators?
Yes, teacher.
Mine is there. Mine is there. I want to teach you how to express these values in our calculator, so that you see that we have not changed the meaning of these. Okay?
Yes.
Before you start using any calculator, first reset it so that you avoid errors. Reset it. Reset your calculators. How do you reset? You press Shift, Mod, then reset all. You press 3, then you press equal sign 2 times, like that. Okay?
Yes.
Now I want to change. I want to change from. I want to write it from standard form to a normal notation, to a normal notation. So I'm going to press 3.2. I think that. Now in our calculator, the times the 10 is already here. I think exponent.
Yes. Yes.
Exponent is already representing times the 10. Are together, members? Exponent is already representing what? Times the 10. So you press exponent there. You see what is displaying for you? Now after pressing exponent, now you press the power. Our power here is what? 3. Then you press 3 like that. What do you get? I think that. I think that. What was our number? I think that.
Yes.
Now also from here, I can change it to standard form. That's from my calculator. Now I will change this one back to standard form. How do you change that? You come to mod. You come to what?
Mod.
Mod. Then look for press mod until you see scientific notation. I think that scientific notation number 2. Fix 2 and then what? I think 2.
Yes.
Press 2. Press 2. Now you see that it's displaying 0 to what? 0 to 9. That's why I said here, we said the number must be between 0 and 9, between 0 and 10, sorry. So ours is it? Ours must be to 1 digit, must be 1 digit. So you press 1. You press what? So when you press 1, I think that.
Yes.
Have you seen that?
Yes, teacher.
Yes, very good, very good. So if you remember, your calculator is still in scientific form. It's still in scientific what? form. If you want to take it back, you press mod, then you press common. You press common, then you press 1. Sorry. You can reset. You reset your calculator, reset, 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 like that. Okay. I want to write 80,300 in standard form. Our answer here we got. Members, have you seen this? I want to change this one to standard form. So I'm going to come to standard form number 2. Now, when you look at this number, this one is to how many decimal places? It's to 2 decimal places here. So you press 2. You press 2. Sorry. There's a mistake there. Let's go back. 2. Then you press 1. So the number is the number is 80,000. 80,300. You press that like that. Are you seeing that? Have you seen that? Members, have you seen that?
Yes, teacher.
Yes, that's how you write it in standard
Yes, teacher.
form. Good. Now, how do you write for negative powers? How do you write for negative powers? Let me just give one negative powers. Let me give one. I have, this time I have this one. What is this one in standard form, members? What is this one in standard form? 153,000 in standard form. You get
1.5.
1.5, 3 times 10 to the power.
To power 5.
To the power what? To the power 5. To the power 5.
To the
Good.
power 5.
Good. What about this one? I have F. Let's go to F. F, I have 609.5. I want to write this one in standard form. Now, this time, the number we have given is already in decimal point, but it said when we are writing in standard form, it must have only a single digit before a decimal point, a single digit. So what is going to be this one? So which means we are going to have 6.09 what?
09.
9 what?
95.
95 times, what will be the power? To the power what? Now you start from here, 1, 2, which means to the power what? To the power 2.
To the power 2.
Have you seen that?
Yes.
B. This time I have 80.32. A number after a decimal point, you call it as a digit. You don't call it as a whole. You don't call it as a whole number. You call it as a digit. So it's 80.32, not 80.32. When you say 80.32, that is wrong. That is not mathematics. You say 80.32. So what is 80.32 in standard form? It's going to be 8.0 2 times. Now you start counting from the decimal point. You start counting from the decimal point. How many steps from that? Because we are shifting this decimal point.
1.
How many steps do you move?
1.
Only 1. Very good. Members, that's how we write in standard what form. That is for positive powers. Positive what? Powers. Let's go for negative powers. Let's go for negative powers. Negative powers. Negative powers. How do you write negative powers? How do you write for negative what? Powers. If you recall, just one from our indices, from our what? Indices. I said if I have A to the power negative n, to the power negative n, we can write it as 1 out of A to the power what? N. If you remember that. Do you remember that, members?
Yes.
From our indices, So which means that implies also, if I have 10 to the power negative 1, which means that number can be written as what? 1 over what?
10.
1 over 10, which is the same as 0 point what?
0.1.
0.1. Very good. That one is from indices. That one is from indices. Now, when we come back now to standard notation, so let's write. So which means we are going to have is written as general form is written as A times 10 to the power negative what? Negative n, where A must be a single what? Digit. A must be a single what? Digit. So let's examples. Write the following numbers. Write the following numbers in standard. Write the following in standard form. Members.
Yes.
What have you discovered
Yes,
when you
yeah.
look at from the indices? Which means for us to have a negative power, which means the number must start with a what? Must start with 0
One.
point. Must be 0 point something, not so?
Yes.
Yes.
So that's when we can have a negative power. So A we have 0.0729. What is that one in standard form, members? What is that in standard form? It's going to be
7.2.
7.229 times 10. Now this time the power must be negative because you are moving. This time you are moving, you are counting the decimal point from left to right.
Negative.
So which means you shall have 1, 2, not so? So which means to the power negative what? To the power negative?
-2.
Yes. You are shifting the position of the negative. So 0 point, another one is 0.426. Who can give us this one? Who can give us that? Who can give us that?
4.6
4.26
4.26 times 10
times
10
10
to the power
to
negative
power negative 1.
Negative 1, because we are moved on a one step, right?
Yes.
You people, you are good. Which breakfast did you take this morning?
Porridge.
Band.
porridge and banana.
Please continue eating that one. That is a very good. It's a very good for you.
Porridge and eggs now.
Okay. Now write for me
Banana.
that one. Write for me that one. Who can give us answer for that? Someone to give us
1.1
1.45
1.45
5.
times
Times 10.
10 to power
times 10
negative
to the power -2.
Very good. Very good. Very good. You people, I don't know even what to say now. But let me. Next one is the next one is 0.000017. Yes.
1.7
1.7 times 10 to the power. How many steps?
negative
1,
Negative.
2,
negative
3,
6.
4, 5, 6. Power negative what?
Negative 6.
Negative 6. The last one. I'm giving on the last one because this thing is too easy for you people. 0.004. Give me answer for that and we proceed.
4.0
4.0
times
0
times 10 to the power negative
10 to power negative 3.
2.
Negative three.
Negative
Negative
3.
3.
Because now 4 is there. So you move 1, 2, 3. Okay?
Three.
So power negative what? 3.
3.
Members.
Yes.
You see, even if I say
Yes,
the last
teacher.
one, but now you just write for me this one. Don't even tell the answer to anyone. Just write the answer in your book. 0.00309. Write the answer in your book. Don't even tell it to anyone. You have finished that, not so?
Yes.
Yes.
Yes. Members. What have you
Eh?
written? What have you written?
3.09
times 10 power negative 3.
Negative?
negative 3.
3.
Negative 3. Perfect. Perfect. Members,
Yes.
is there any question on how to write standard form or scientific notation for both positive
No.
and negative powers? Is there any question there?
No.
There's no question, right? Now, if there is no question there, now let's go to our topic now, logarithm. Can you write logarithms? Logarithms. In capital letters, logarithms. In bracket, just write log. The short form is log, okay?
Yes.
Yes.
You know, for us mathematician, we don't want things that take a lot of time. We want to save time always. So instead of calling logarithm all the time, we just call it what?
Log.
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 Members,
Yes.
logarithm is another way. When we talk of logarithm is another what? Is another way of expressing. Is another way of expressing numbers. Is another way of expressing numbers in power what? In power?
Form.
In power form. There was this great mathematician. It was introduced by a man called John Napier. He's called John what?
John Napier.
John Napier is the one who came out with it in the year 16. Can you imagine? In the year 1614. Okay? Okay?
Yes.
Yes, and the man is a Scottish. He's a Scottish. He's a what? He's a Scottish who came out with that, which means from Scotland, not so? Which means from where?
Yes.
He's from Scotland.
Scotland.
So he came out with that concept because there were very many ways we can express numbers in power form. Then for him, he said, now there must be another way of expressing large numbers. There must be another way of expressing large what? Numbers, apart from using indices. Because there are certain numbers, because indices just give us in the power form, not some members.
Yes.
Yes, that's why one of the application of logarithms is the magnitude. When we want to measure the magnitude of an earthquake, magnitude of what? Earthquake. Members.
Yes.
We always listen to news. We said earthquake has taken place in this and this place, not so?
Yes.
Now, when you see the figure they are giving you, they say the earthquake was magnitude of 5.0. The earthquake was a magnitude of what?
5.0.
No, they are not meaning that is only 5.0. Don't say that the magnitude is very small. It's very big. Why? Because this one they're expressing it in what? This one have been expressed in what? In what? In logarithm. Are you together, members?
Yes.
Members, are we together?
Yes, teacher.
No.
Yes, please, teacher.
Members, are we together?
Yes.
Yes.
So in a simple sense, when we talk of when we say the earthquake is of magnitude of 5.0, we are meaning, which means because logarithm is always, Napier was trying to express numbers like we see here, we are multiplying everything. We were multiplying everything by 10. So which means must be a multiple of 10. So which means
Yes,
the number
sir.
that I've given here is a multiple, which means it's to the power of, it's 5, 10 to the power of 5. So which means the base. So they're telling you that that earthquake is of magnitude of 10 to the power 5. That's what, in a simple sense, that's what we are saying. So which means what is 5 to the power 10, members? What is 10 to the power 5? Members, what is that? Members, what is that? 10 to the power 5.
100,000.
That is it?
100,000.
100 what? 100,000. So which means the magnitude of this earthquake is it? 100 what? 1,000 is 100,000. That's the magnitude of this. But now when we are giving them, we just give them in a simple way. We said the earthquake is of magnitude of 5, which means every number must be expressed to the power what? To the base of 5.
10.
So when they said earthquake was magnitude, when they said is of magnitude, earthquake of magnitude 2, earthquake of magnitude, which is very low, which means they're saying is the same as 10 to the power 2, which is the same as what? 100. Members, are we together?
Yes, teacher.
Members, are we together?
Yes,
Yes.
teacher.
Members, are we together?
Yes, teacher. Yes.
Yes?
Yes,
Cynthia, are you
teacher.
getting me?
Yes, teacher.
Cynthia, you are talking, but I'm not getting you.
Teacher, I'm getting you.
Yes?
Yes.
Okay. Members, are we together?
Yes.
Good.
Yes, teacher.
Okay. So we are saying logarithm was introduced by a man called John Napier in the year 1614.
14.
And John Napier is a what? He's a Scottish, he's from Scotland, a great mathematician. He's a great mathematician who came up with that idea of logarithm. So, and one of the application of logarithm, because for him, he was trying to investigate how can we express earthquake. The instrument that we use for measuring the level of earthquake is called rectimeter. It's called what? It's called rectimeter. So the machine that we use, to measure the magnitude of an earthquake. That's why you see that people we talk of those who want to become great geographers. Those who deal with the weather forecast. Yes?
He's still there.
Hello? Joe is not there. He's no longer there. He's no longer there. He's dead long time. But now you can see when you do great thing in life, even if you die centuries back, people will still remember. You can imagine. Scottish discovered. It was published. His first work of logarithm was published in 1614. But he died long time ago. But you can imagine, we are in 2021, but we still talk about him. Are you seeing the impact of being a great man or a great woman? Yes. Some if you die in 2020, 2021, by year 2026, no one will remember you. Apart from your family members. Apart from your family members.
What about
Yes. Now, members.
Yes.
That's all about logarithm. That's all about what?
Logarithm.
Logarithm. So we are saying powers of 10 and logarithms, power of 10 and their logarithms. So like I was explaining to you, when we talk of powers, large powers, expressing large numbers in standard form, we want to find a way of that we can express numbers to the power of, to the base of 10. To the base of what? 10. Why are we drilling to the base of 10? Because our calculator members, our what? That's why when you see, I seeing logarithm from your calculator there, from my screen, I seeing logarithm.
Yes.
Then there's that part where they put 10 to the power x. I seeing 10 to the power x.
Yes.
So it means our calculator has been programmed to log to base 10. Our calculator has been programmed to log to base what?
Base 10.
To base 10. So take note of that. That's why whenever we are dealing with the only logarithm that we can put in our calculator, that log must be to log to base 10.
10.
Yes. Good. Then another thing also. Are you able to see my notes, members? Are you able to see my notes?
Yes, please, teacher.
Yes. So we said, suppose I write log A, B, log A what? A, B. It is written or read as, it is what? Written or read as logarithm of B, logarithm of what? B to base what? To base what? Base A. So A is our what, members? A is our what? Base. Then B we call it argument. B we call it what?
Argument.
B is called argument. So when I write like this, so I said, if I write log of A, B equals to C. Are you seeing that, members?
Yes, teacher.
So A, I said A is called what?
The base.
B is called what?
Argument.
Then C is called the power. It's called the what?
The power.
Or what? Or what? Or exponent. Or what?
Exponent.
Or exponent. Members, we have just seconds. So when we get off, we shall come back and then we continue from there. Are you together, members?
Yes.
Yes. I said A